Example 7, and on page 187, we are told that the random variable x is distributed normally within the mu and the variance, or rather the standard deviation squared, both of which are not known. Given that the probability of x when it is greater than 35 is 0.05, and the probability of x when it is less than 15 is 0.1469, find the value of the mean and the standard deviation, or rather the mu and the standard deviation. And of course, now what we are faced with is a situation whereby we have, when x is greater than 35, this region, the area is 0.05. And when x is less than 15, this region, the area is 0.1469. How have I learned that 35 is on the upper? Because we have to have 35 is an unfamiliar boundary. We have to bring in y, which might be our familiar boundary, and w, which will be our familiar boundary. But of course, when x is greater than 35 and the area is far less than half, then it is so much close to the end. That means it is to the positive side. And when x is less than 15 and the area is far much less than half, you can see 0.1469, then it's just a small portion to the left, so w will obviously be negative. Having understood that, let's go directly to probably the percentage table, because 0.05 looks very conspicuous. We might find it there. We might find it there because, yes, the greater than allows us to do that. 0.5, and yes, it's there. And z, as far as which is in this case our y, is equals to 1.6449. 1.6449. This one is so much associated with that. So let's go to when x is less than. Let's go to w. And of course, if we may have a diagram that represents that, just that portion alone, and we are talking about less than, whereby we are having our w there, which is obviously going to be negative, and this is the region 0.1469. By symmetry, there is another w there, and this region is also 0.1469. And of course, we are looking for this particular w, which is the boundary rather. And at this point, we can say, when we add this region plus this region, we are looking for the boundary. So the probability of z less than w plus the probability of z, we have introduced the z, but we are coming, greater than w is equals to 1. But this probability of z greater than w is here. So the probability of z less than w is 1 minus 0.1469, which is basically which is what? Which is let's see, 1 minus 0.1469, which is 0.8531. So we now go to the table on page 201 and we identify this probability. Of course, the probability of z less than z, we should expect something to do with 0.8531, and we should expect the matching or the corresponding, the Z. Let's get there. Page 201. 8531 it is. 85, yes, and our Z is 1.05. And remember, what did we say? Our Z is going to be, or our Z is going to be negative. So W is negative 1.05. And yes, Y is 1.6449. As much as we know, we are not through with this question yet. As much as we know, Y, which is 1.6449, is associated with an unfamiliar boundary, which is 35. So we know very well, if this is the boundary, which is our Z in the table, let's call it Z1, we can say that 35, which is unfamiliar boundary, minus the mu over the mean over the standard deviation, it should have given us this boundary now, 1.6449. And what do we know about this? This is just like saying 35 minus the mean is 1.6449 times the standard deviation, and we could call that equation 1. And we have taken care of the Y, which was very much associated with 35, which you brought here. What about the W, which is negative 1 point? This one is so much associated with 15, and the unfamiliar boundary in this case is 15. So we can easily say that 15 minus the mean over the standard deviation, it should give us minus 1.05. Cross multiplying, we're going to have 15 minus the mean is minus 1.05 multiplied by the standard deviation. And we can have this one as equation 2. Having understood that, then we can bring the two equations together. We can bring the two equations together and solve them simultaneously now. And we have 35 minus mu is equals to 1.6449 standard deviation, and 15 minus the mean is equals to minus 1.05 multiplied by the standard deviation. And in our early years, when we were talking about solving simultaneous equation in year 9 and year 10, we came across the word we called DAS. And in DAS, we said that when we are dealing with different signs, we add, and we are dealing with the same signs, we always subtract. Of course, we don't have to multiply out with anything, because the mean and the mean, they both have the same coefficient, which is a 1. And because they have the same signs, negative and negative, yes, equation 1 minus equation 2. That means that 5 minus 15 is 20. This one is 0, is equals to 1.6449 minus meaning plus 1.05 will give us 2.6949 standard deviation. And at that particular point, standard deviation is simply 20 over 2.6949. So 20 divided by answer will give us 7.4214. That could be our standard deviation. But yes, what is our mu? If we substitute this in any of any of these equations, then you're going to have our mu is, if you want to make this one the subject of the formula, is going to be 15 plus 1.05, our mean, and the standard deviation, which is 7.4214. And what is this? Let's get there. Yes, that times 1.05, which is that, of course, plus 15, which is giving us our mean is 22.79. And that's where we are. Please take care. Please take care. You can see what is required of us. This question combined everything. We were talking about a region that is between two boundaries, and we have been able to calculate our mean and our standard deviation. So either way, you will get home, and that is awesome.